Okay, now next problem. Now this is the graph of the function f of x. Now you can see that the function has minimum in here, then it has a maximum in here, and it has a minimum again in here. So from the graph we can easily determine our max mean. So we can say we have minimum at x equals -3, and the value of the function at -3 is say -500 according to this diagram here. And then at x equals 2 we have another minimum. This one is -300, and then we have max at x equals 0, and that maximum value is 200. So we have seen all this stuff. Now the interval of increase, decrease. So first you can see here the graph is decreasing from -infinity to -3. Then it is increasing from -3 to 0. And then again it is decreasing from 0 to 2. And then again it is increasing from 2 to infinity. So we see f prime is 0 at -3 because you have a horizontal tangent, and then at 0 and also at 2. Now if we see the sign of f prime, you can easily see all the tangents you draw here until -3 all are having negative slope. So then negative here, and then from -3 to 0 now it is going like this. So the slopes are positive, meaning is derivative is positive. Same way we get a negative here and get a positive here. Then we say that our function is decreasing here, then it is increasing, then again decreasing, then increasing. So then we can say that we have minimum at -3 is here, then we have maximum at 0 is here, and then again minimum at 2 here, and then it goes like this. So the interval of decrease will be -infinity to -3 is going down, and then from 0 to 2 going down. And the interval of increase will be -3 to 0 and then 2 to infinity. So you have seen all of this. Now I'm going to the third part, when derivative graph is given. In third part, now this graph is no more the graph of f of x, it is the derivative of f of x. It's a different question. So then what we see now, f prime is 0, where we can easily see this is 0 at x equals -4, and then this one you can say -2. Then we have at 1, and we have at 3. So following the same process, we make the line test. So then first we say f prime is 0, we have at -4, -2, at 1, and at 3. Now we need to check the sign of f prime. Remember, this is the graph of f prime. So this portion here is positive value of f prime. So then left side of -4 f prime is positive. And then from -4 to -2 everything goes under the x-axis, so it is negative. And then -2 to 1 everything above is positive, above x-axis. And then again you go from 1 to 3 is negative, and then after 3 it is positive. So then what we can say, our graph is going up, then it is going down, then it's going up, again it is going down, and then it's going up. So then at -4 what we have on the function is max, and then at -2 we have minimum, at 1 we have max, and at 3 we have minimum. So the interval of increase decrease also we have got. Negative infinity to negative 4 is going up, negative 2 to 1 is going up, and then 3 to infinity going up, increasing. And the graph is decreasing in the interval negative 4 to 2, negative 2, and then 1 to 3. Now we have another part to do here. To see where the function is concave up and concave down, we need to check the sign of second derivative. Since this is the graph of first derivative, so we know second derivative will be 0 here, here, and here. So we list those points. Second derivative will be 0 at x equals negative 3, 0, and 2. Okay, so we see second derivative is 0 at negative 3, at 0, and at 2. So the sign of f double prime. Now you can see this is the graph of f prime. So if I take the derivative again, then with tangent on this. So you can see all going down like this, negative until negative 3. So here negative. Then you can see the tangents here going up. So then negative 3 to 0, it is positive. Then here's negative, then it is positive. F prime is going down here. Then it is going up here, going down here, going up here. Now what happens to f? When the f prime is going down, then my function is concave down. And then when derivative is going up, first derivative, so then it is concave up. Then you have a concave down, then again concave up. So the graph of the function is concave down on negative infinity to negative 3 and from 0 to 2. And then it is concave up on negative 3 to 0 and 2 to infinity. So then we can say negative 3 is inflection point. 0 is inflection point and 2 is also inflection point. So you have got everything. I hope you have understood how to analyze graph and find max mean when you are given algebraic form of a function, or you are given graph of the function, or you are given derivative, the graph of the derivative.